Already when I was born, my grandmother expected me to become an engineer. There was this famous engineering school named Chalmers University of Technology in the city where we lived. And she had high hopes that I would attend it. And it so happened that when it was time for college, Intel released the first microprocessor, and I was blown away with it and wanted to learn everything about computers. So my grandma's vision became reality. I started out in the robot industry in 1976 when I joined the small team at ASEA in Sweden, now ABB, that developed the world's first all-electric microprocessor controlled robot, the IRB6. Although we had no PCs, no internet, and no mobile phones, we were able to create a robot that was not all that unlike the ones we make today. After a few years as a developer, I left ABB to work with system integrators and end users in Germany, where I got a customer perspective on robotics. In 1985, I was recruited back to ABB to start an R&D department in Milwaukee, USA. There I had a chance to build a new team from scratch, something I really enjoyed and have been fortunate to be able to do several times again. We often hear that technology advances extremely fast, but I beg to differ. The things we were working on in the 1980s that we today would call IoT, digital twin, and AI are yet still just on the verge to become pervasive. After more than a decade in the US, I moved back to my native Sweden to start a new company named Digital Plant Technologies. The business idea was to develop tools to create what we then called digital replicas of real manufacturing systems. But we were out too early. It was too difficult to build digital twins of all the equipment in a factory. Often we didn't even have 3D models. So the company was acquired by ABB, and the scope was limited to ABB robot systems. We already had digital twins of these as a result of the work done in Milwaukee. We named the product RobotStudio, a trademark that has since earned respect among customers as well as competitors. The secret to success of RobotStudio is that it runs the same software that is running on the real robot controller. So what you see in RobotStudio is exactly what you get in the factory. That makes it possible to do virtual commissioning, designing, testing, and verifying a new manufacturing system in the virtual world so that the startup in the plant goes fast and you can quickly ramp up production to full capacity. Already when we first started to develop RobotStudio, we intended it to run in virtual reality. The technology was available, but was too expensive to be commercially viable. So RobotStudio was confined to flat displays for a long time until it could finally be released in 2016 when inexpensive consumer devices became available. In RobotStudio we were early adopters of VR. A particularly useful feature has been VR meetings. That has made it possible for users in several locations, including from home, to meet as avatars inside RobotStudio to collaborate on robot solutions. An even more promising technology is augmented reality. Being able to visualize robot paths, work objects, and safety zones in the factory will make it possible to use RobotStudio with real robots in the same way that it is used with virtual robots. And devices such as teach pendants that today are physical can be replaced with virtual ones. Just to mention a few of all the new possibilities that the metaverse will enable. I am proud of what we have accomplished this far, and I am really looking forward to the journey ahead.